Section 7.4 is about evaluating what we call logarithms. There's going to be a lot of new stuff coming at you in this section, so really try and pay attention while you're taking these notes. First off, I wanted to start out, you know that 2 squared equals 4, and 2 to the third equals 8. However, what if we were looking for 2 to what power gives us 6? Well, we know it can't be just a nice integer because 2 squared equals 4, 2 to the third equals 8, and 6 is somewhere in between there. So when we don't have an exact x value, we need to use what's called logarithms. And that's what this whole section is about, is logarithms. Here's the definition of a logarithm with base b. This right here is the form of a logarithm, and b and y are positive numbers. B is never 1, and b is your base. That's why this is the definition of logarithm with base b. B is your base. So this is log base b of y. And I have a little note down here, that's how you would read that, as log base b of y. Here are two different forms of logarithm. This is logarithmic form, and this is exponential form. In this section, you're going to learn how to go back and forth between each forms. So this is log base b of y equals x, if and only if b to the power of x equals y. So you're going to be flipping back and forth between these two forms, and I have a couple ways to help you remember how to do this. Hopefully it helps. Let's take first if we were in logarithmic form and we were trying to go to exponential form. So we want to change this right here into exponential form. To do that, you're going to think of Froggy the Luggy. You are going to make a little frog to help you remember how to move this. Start with the b, and you're going to make a little loop to each number. So loop, loop, loop all the way back up to y and to b. And this is supposed to be your little frog right here. One of his eyes is a little engorged, but just ignore that. And that's how you're going to move your letters. You move your b up here, y goes on the other side of the equal sign, and x goes up here to become the exponent. So you move b up, move y to the other side of the equal sign, and x becomes your exponent. So you've moved it to that form. Now if you're going the other way, if you're given exponential and you have to move to logarithmic form, the only thing I got for you there is you're going to go just exactly backwards. So x is going to come down, squash y and kick him over, and b is going to be put down in the base. So moving the other way, x comes over on the side of the equal sign, kicks y down, slides him over, and b becomes the base. So hopefully that'll help you out when we're doing these examples. So first thing, we're going to move from logarithmic form to exponential form. So that means make your little frog. Start with the base, make a loop, 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 and just follow your loop. 2 moves up to where the 32 is. 32 moves to the other side of the equal sign. And 5 moves up to the exponent. And you're done. Here we do the same thing. Make your little loop, little frog face. If you don't think it looks like a frog, too bad. Just pretend it looks like a frog. Move your half up to where the 2 was. Your 2 goes on the other side of the equal sign. And your -1 moves to the exponent. And if you have a fraction, make sure that fraction stays in parentheses because this whole thing is to the -1 power. That's all you have to do for those. Let's look at special logarithmic values. First we're going to look at the logarithm of 1. If you have log base b of 1, any log of 1, no matter what the base is going to equal 0. And this is because the only way we can get a 1 here is if this equals 0. Because the only way to get 1 is to have a power of 0. So any log of 1 equals 0. If you have a log and the base and this number are the same, it's going to equal 1 because the only way we can get these to be the same number is if this equals 1. So if you have a log of 1, it always equals 0, and if you have the same base and this number are the same, it's going to always equal 1. So if you have the log base 14 1, and they ask you to evaluate that, the answer is 0. Because any log of 1 is 0, no matter what the base is. Log 5, 1, gonna equal 0. Log of 1 always equals 0. Now look at the other rule. If you have log base 5 of 5, your answer is gonna be 1. Anything that you're taking the log of, if you have the same base, it equals 1. So if you have log base 72 of 72, the answer is 1. That's how those rules work. So let's evaluate some other logs. If you're looking at something as log base 3 of 81, you can use the rules you just learned to rewrite this and solve. If you want to know log base 3 of 81, what that equals, you're looking for what that equals, just use your rules to rewrite it. You move your 3 up, move the 81 over, and move the x to the exponent. So this becomes 3 equals 81 to the x power. So you're thinking 3 to what power equals 81? And the answer is 4. So log base 3 of 81 equals 4. Same thing here. You're going to have 5 to the x equals 0.2. I just used those rules to rewrite this. So you're thinking 5 to what power gives you 0.2? Now this is a little bit tricky. 0.2 is less than 1. So obviously this is not going to be a positive integer because 5 squared is 25. So you have to think negative exponents, because negative exponents will flip your number. So if we had x equal -1, well, 5 to the -1 does equal 1 over 5, because the -1 flips your fraction, if you remember your exponent rules, and 1/5 is 0.2. So the number you're looking for is -1. So log base 5 of 0.2 equals -1. We'll do one more. Here you have a half to the x equals 8. So you're thinking a half to what power gives you 8? Again, if you think about it, a half squared is 1/4, and a half to the third is 1/8. So we're getting farther and farther away from 8. We're getting smaller. So you need a negative exponent that's going to flip this over. Well, you know, I just said a half to the -3rd gives you 1/8. Well, what if that was flipped? That would be 8, right? So if you had a half to the -3rd power, that would mean you would have to flip it to make it positive. So it would be 2 to the 3rd, which is 8. So that means our x needs to be -3. So that means log of base 1/2 of 8 equals -3. Those will take some practice to get used to. So I have another rule for you. We have a common logarithm and what's called a natural logarithm. A common logarithm has a base of 10, and it's denoted using log, log. And if you have log base 10 of x, that's the same thing as writing log of x. We just know that log has a base of 10. It's just known. So you don't have to write 10 there. If it has a base of 10, you can just write log of x. Then there's something called a natural log. And a natural log has a base of e. And we denote a natural log with ln. So if you have a log base of e, you can rewrite that as ln of x. Natural log is ln of x. And some of these you can't evaluate in your head like we were just doing. You need a calculator. So I'm going to show you how to use your calculator to evaluate these. It's really pretty simple. You're just going to use the buttons log and ln on your calculator. So if you're looking for log of 5, the button for a log is right here, and you just hit log of 5 and hit enter, and you'd approximate it as a decimal, like round 4 places. The LM button is right below it. So natural log, right there, ln, and you would just type in 0.1, and you would hit enter. So that's how you use your calculator to approximate the ones that you can't do in your head. The last thing I have for you are inverse functions. Just like any other function, this has an inverse. So log base b of x is the inverse of b to the x power. So this means that if you have log base b times that same base to the x power, it equals x. Since these two are inverses, if you have them multiplied times each other, you should get x. And if you write it the other way, if you have b to the log power times b to the x, you're just going to get x. So let's look at some examples to try and make some sense of all those different letters. Remember I said that the base of just a log is 10. So really, I can write this as 10 to the log base 10 of 2. Since these are inverses, it's like these cancel out, and your answer is 2. That's simple. Here what we're looking for is we want the base and this number to be the same, so that then we have inverses and we can get x. In order to do that, these two numbers have to be the same. So our goal is to try and get 9 as 3. Well, we know that 9 is also 3 squared. So we can rewrite this as log base 3 of 3 squared x, because 3 squared is 9. This is the same exact thing. So since we have the same base and this number are the same, it's like these cancel out and our answer is just 2x. Now when I say cancel out, let me explain. Before in the video, remember I said if you had log base 3 of 3, what does that equal? And if you have the base and the number you're taking the log of is the same, it's always 1. That's what happened here. You had the base and this number are the same, so really that crosses out and it's just 1. So you're left with just 2x as your answer. So in class we're going to talk about graphing these, and then you're going to do a lot of practice of going back and forth between forms, because getting this takes practice.